vision, image processing, and intelligence systems. He has published research papers in reputed international journals and conferences and has actively contributed to interdisciplinary research combining mathematical modeling and AI-based solutions. His academic interests include computational intelligence, optimization, and real-time intelligent applications. Okay, Professor Jaiswal, please continue now.
Thank you so much for giving me the opportunity. So, our presentation is from machine learning and network. Is generated with a network. So, we are working here on the various diffusion model. One of them is the GAIN, generative adversarial network. But before going in, try to get network, I will try to just give some info on what's the adversarial network and what is the machine learning and some more points. Right now, I am explaining where the machine learning. The machine learning is a set of the AI where we try to input some kind of intelligence to the machine. So that automatically decision without human interface. Machine learning. Even if you don't any kind of but still, it is also on using the and how it is possible for machine learning to take the student in the machine learning is different from the normal computer program. Here, the developer and the software developer is not the machine. So how to get the action when we encounter any new kind of situation. It is the human interface. So this one is the programming approach. When the machine learning approach, where you can see there is no programming already. Provide the data and the program to the computer system, and the computer system allows the processing of the data and the program. And after analyzing the data and the program, it is the
Hello. Excuse me, sir. So there, like, it is a very noisy background. So can you put a microphone or something like that?
It's not wearing a headset.
Sir, actually, your voice is not clear.
Are you holding a collar mic?
I'm wearing a collar mic, so I'm listening.
Please try to adjust if it is possible.
Yes. Hello.
Yeah.
Yeah. How my audio is clear, sir?
It is little better, but little noise is still there. It is going.
To the network restriction. I mean, here we have network limitation. I mean, So, even the machine learning model, we will provide the data in the form of label data, then we also provide some kind of the machine is the computer, and the computer after managing the data and the label out will generate the program. So, after generating the program, we have the advanced system, they will be the decision without the human interface. Now, there are four kind of machine learning systems. One is the supervised, second one is the unsupervised, third one is the reinforcement learning, and fourth one is the generative AI. You know, in case of the supervised learning, we have some kind of supervisor each and every time we provide some kind of supervision. It is a kind of for example, making our classroom teaching. We have the professor in the teacher in our classroom. They provide the guidance and each and every moment only how to perform the solution for the complex task, and they provide the each in one direction. So for example, they give the direction to the student after performing the step one, what step, and after performing the step two, what the step five. So in case of the supervised learning, we have some kind of solution with us. Quite result machine learning system, and basically there are two types of supervised learning. One is the regression, and second one is the classification. Well, in the case of unsupervised learning, we don't have the supervisor in the level there with and every time. So here the machine try to figure out the hidden pattern. You can imagine taking a class without a teacher and without a professor, and we are just asking the student to provide the output and what the output for a given question. So it will be difficult for the student to provide the output and the answer. But once the student try to figure out the option of the question, they will provide the output very easily. And in the making of machine learning, we are using the unsupervised learning. This example of unsupervised learning that we can apply is the clustering. It's a very good example. In clustering, the cluster of data is selected and where the similar kind of group, the similar kind of point or the similar kind of data will together in the web stores, and the different kind of data, they fit together in the another export. When we talk about the reinforcement learning, it is a type of machine learning system where we try to some kind of reward and punishment for the machine. It is a very good example for us that a very little child try to figure it out and try to figure out some question from the parents, but the child needs a very answer and the very without the child gives the wrong answer and the unrecommended information. So, reinforcement learning is a very good example of that. Very similar to the child is learning from the zero, from the distance point of view. Now we come on the generative AI. It is a kind of the reinforcement learning when we try to then the robot will perform the task. So it is similar to the reinforcement learning, where here like the feedback machine that the machine has some kind of from the students. For example, we try to train the robot to work on the unpredictable, but when the robot faces some kind of obstacle on the road, the robot and so then there might be some kind of obstacle in the road. So next time when you see any kind of obstacle and any kind of hurting on the road, they try to figure it out what is the next step. As I already told, supervised learning is very similar, like the teacher and the supervisor each and every time, and we have the table data we have in the supervised learning. For example, in the supervised learning, we have the data set of the element in the HTML and the cloud. In the supervised data, we provide to the machine. And after seeing the data, we apply some kind of algorithms to the computer system. And after processing the data, the computer system is whether the given data capability of the endpoint or the cloud. The use case of the supervised learning include the relation and relation classification here. You can see here we have the label data. In the label data, we have the cloud at the elephant, and here we have the cow, elephant, and the human level. And together works with algorithm. in this level data in the level after processing, you are using the algorithm after process and after processing the complete system is able to identify whether the user is showing the camel or the cow. A good example from the supervised learning. Here I am just to step and good example for us. We have the bucket from the there we have the banana, elephant, and the now that my interpretation is now there is the banana belongs to which category? Where they belong to the one, they belong to the second. It is possible that we can identify the texture of the elephant, identify the texture of the identify the texture of the banana, but how is it possible for the machine? So the machine identify using the label data. The label to question the very picture of the particular picture. For example, suppose the machine that by showing the food one by one. For example, doing the smart depression in the top and it is red, and the machine identifies it. So the initial, and then we identify visible. So after the training, we use the machine to take food. For example, we are providing the ananas. The ananas, it is the texture in the yellowish texture and some leafy. But after identifying the texture of the ananas, like a piece of texture in some greeny, the machine identifies it with the and differentiate with the apple and differentiate with the banana. So, yes, the technical data will be useful. We are trying to figure out whether the known food category belongs to the banana or whether it belongs to the apple. So, now I come to the supervised learning. Supervised learning can be recognized with first is the regression and the second is the classification. The regression, we have some very classical algorithms like the linear regression, polynomial regression, the lasso regression, and the range regression. Basically, in sense, like the continuous value, such as the house regression, the house regression, the house. How many square feet it is, how many story it is, like the first floor it is, the second floor it is, and after the first provide the depend on the construction system. We provide the continuous value the data, or maybe it will be the feature like the story and the number of spaces of the land area. Now we come to the second type of supervised learning, the classification. In the classification, the algorithm system tries to identify the given data belong to the particular category of the suppose if we are using the system, the face of the human and the face of the animal, the system will be able to identify the particular data set belong to the category of the human and the belong to the animal. The classification algorithm for the classification of the integration, support vector machine, diffusion key, and the random forest and the bias. So, in an algorithm, the unsupervised learning methods, we have the programmable and the capability, and the machine by their own and the question from the hidden data and identify the relationship between the data. It is a very good example of the unsupervised learning here. You can see we are providing the input of the raw data, but instead we are providing only the image of different human and the power. Here we are not providing any label data to the machine. So here the output are not machine, and there is no training data set available to the machine. The machine here figure out whether the particular is belong to the elephant category, or if we belong to the German category, or if we belong to the cow category. So supervised learning is the right now most of the system are using the supervised learning. So we can divide the supervised learning into class skills. So in this class, we have the learning testing, hierarchical testing, and the PCA, with decomposition, independent component analysis, and the Gaussian mixture model, again treating this discussion testing or application with the knowledge. We have some application of the machine learning system, which include the traffic prediction, virtual personal assistant, automation translation, online fraud detection, medical diagnosis, text and increase information, reasoning, and some more. So now I had come to the first important network is kind of unsupervised learning. Hello.
Yes.
Hello.
Yes, Professor. Hello.
How are you? Yeah. Thank you so much, sir. When we talk about the game network, it will come from the answer machine learning system. Basically, the game network come together with it. One is the different what is the generator. So basically, network virtual training, and the game network are trying to carry out the data and using the random lines, and when the generator distinguish between the real data and the data information data in the job, there are this kind of game network available like the game, DCN, or the CCN. I prepared a very good example of the game using the IQAC here. You can see we are having the random knife with us here. This random knife is supplied to the generator. This random knife, when we supply to the generator, it creates the whole combination. You know, it's like, for example, you can consider the people are trying to make complicated, and there is some police band, or they are trying to figure it out, but currently printed by the counterfeit people are real or not. So you can consider the generator as a counterfeit people. Let's say this guy. Here the counterfeit people like generator and trying to teach a new step. They try to generate the actual image, but this is here the flag. And in the real data will they try to spell it out in this way. They are generating the static currency here. Here you can understand this is the generator, the counter. They are trying to publish the 1,000 rupees notes, and they're trying to work in the market. So here we have a discriminator. The discriminator is another thing of the hood. The generator will generate some kind of image very similar to the real one. But when the lead guy here, the discriminator sees this image, it is like to no, he called them, and then he told it. The connection generated by the algorithm people using the phone. And they try to call a product and connectivity with them. And again, after getting the information from the products, the next component will come into the scenario. And they try to figure out your issue. This time they are generating the thinker and the very enormous image of arbitrary mode. So we find that this is try to really whether the generated image of the side of this not really real or the fake, but that the distributor try to figure it out the generated image by the people are very real. So they provide some kind of very decision maker, or they provide very low kind of techniques or recruitment. So this kind of see to generate the artificial image. So I mean, this is the needs of the gain network consists of the generator and the distributor. And the next thing is here that the generator and the distributor and there's a mean makes here. So until the generator try to figure it out that they are generating the very real or the very good 2000 rupees for money. Takes care. Yeah, like it is a very simple function, and this is in the adjustable parameter here. And which are the generator and the parameter and the discriminator. And by computing in the mean mix game, the generator and the discriminator when the output generated by the generator resistor or the clock. So right now in our game we are trying to generate from using the gain network for the various kind of image. Here you can see we have the right number of image with us. But here the large amount of data set from the and there are some data set available from the data set. This data set was not produced by the definition of the image. So we have going to step the entire web in the Google and also collected some images from the in the images are near about more than 2,000 images in the root file first images of the image and when we the picture, we can see here here we are providing some the render life will be generated. Similarly, here we have the description of the image here. Here we have the real description of the understanding in the output generated by our population model. In our table, we have the good prediction of the image. Our gain network generated the large group of independent different combinations that exist. So here, the discriminator not only identify the animal, but they identify the category of the animal, like the elephant, and then the large group of the you can see that there are not a single elephant. There are 1, 2, 3, 4, 5 elephants. They are only next to each other. For example, we have the image of the zebra, which is different in some state of it. Using our gain network, we try to identify whether the zebra is descending on the field and having the way the sort of the zebra is the flying. Similarly, here you can see the third image. This third image, I mean, for example, if you basically normal person. The normal person will identify in this screen where there is some kind of glass window and there is some person and there is some kind of picture and some kind of pain, our pain of picture. But it's very difficult to identify from this kind of feature and this kind of feature in computer systems. But it was training and using the gate network, in our case, we have tried to figure it out what is from the image here. And then we can show our the game network here identify not only the train but also so the train station with the window and not only identify the way. It's you can see here four percent. To the different in the close in program. But here our system not only the illness will not only identify the woman, the elephant, but they identify their action in what kind of action they are communicating systems. Here the women are holding the banana and trying to clean the wind elephant. When we talk about the fifth image here, you can see the picture of the umbrella and the picture of the two persons sitting inside the umbrella. The normal system is trying to identify, if you give this picture in the normal identify the emission between each and for the so similar results. First person will identify the new umbrella. You do the same picture with second person will identify the third person will be inside the umbrella. And if you do the picture to third person, and they will say that the people having some kind of need. Using some kind of, from the same kind of prediction, our game model identified not only the people, but identified the umbrella, but identified their external movements. So, it's an example to be able to compare actually working on the game network here. There are some references that I have used for network that we use our lab for the Thank you. If you have any question, kindly ask me, please.
Thank you, Professor Jaiswal. You have started from type of machine learning to supervised learning to generative AI. You have covered in a brief span of time. You have covered a lot of topics, and also you have shown application of machine learning, particularly generative adversarial network, where you have shown that even from distinction of fake currency to real caption of photographs, all everywhere this machine learning works. And in fact, let me tell you, recently we have in India we have completed a world summit on artificial intelligence, and I hope people like you working in this field, machine learning and artificial intelligence, you can contribute and you can enthuse our new generation in the movement of AI. Any question? Thank you very much. Any question? Okay, I think that is all. Thank you, Professor Jaiswal. Hope to meet you soon.
Thank you, Professor. Mainly, freshman level numbers will be information.
Thank you.
Now, may I